Redox titration. My students, today we are going to look at redox titration. But I want first of all to define the term redox titration. In redox titration, this involves both reduction and oxidation reactions taking place simultaneously. Then in these reactions do not require indicators because color of reagents change when their oxidation states change. My student, what is the objective of this lesson? There are two main objectives. One, how to complete the iteration tables. Then two, to see how it is simple on calculation of redox titration. Remember, I have found out that many students, after completing the titration table, they normally shy off from carrying out calculations that are below the titration table. So this lesson is meant, my student, to encourage you and equip you with skills and knowledge on how to carry out calculation on the iterations. Therefore, if you listen carefully and you watch carefully to the end, you will not remain the same. Is it okay, my student? Good. Let us look at what the question is all about. So, my student, you are provided with the following reagents, that is acidified potassium permanganate 7 labeled as solution A. Then number 2, you have been given aqueous ammonium iron 2 sulfate solution. This is labeled as solution C. But look at the content. When you look at this solution of iron 2 salt was prepared by dissolving 23.5 gram of the salt in 1 liter of solution. So the concentration of this salt is 23.5 grams per liter. Then also, my student, you will discover that in redox titration, these two reagents, one, this acidified potassium permanganate 7 solution A, is an oxidizing agent, whereas aqueous ammonium iron 2 sulfate solution, this is a reducing agent. So always there are two reagents in redox titration. One, an oxidizing agent, another one, a reducing agent. Is it okay, my student? Let us see what we are required to do in this question. So you are required to standardize potassium permanganate 7 solution A using solution C. Let us go to the procedure. Procedure number 1. And my student, procedure will always mean a lot. So when carrying out the procedure, in fact, that is all about the whole practical. So 1, fill the burette with solution A. And what is solution A? From what you have been given, solution A is acidified potassium permanganate 7 solution. Is it okay? Then procedure number 2, you pipette 25 centimeter cube of solution C into a clean conical flask. What is solution C? Is aqueous ammonium iron 2 sulfate solution. So that one will go into the conical flask. Is it okay, my student? Then procedure number 3, titrate solution C with solution A until a permanent pink color just appears. Then, my student, you now record your results in the table 1 below. But before you complete the table, remember, always you are given the volume of the pipette used. In this case, the volume of pipette used is 25 centimeter cube. Is it okay, my student? Then let us carefully now look and study at this table. In this table, you have been given 3 columns of the iteration. The first column, the second and third. So meaning you carry out 3 iterations. But also you have been given the initial burette reading, final burette reading, and volume of solution A used in centimeter cube. So when it comes to completing the table, my student have been always telling you, it's all about looking for marks. After all, you want to pass your exam. So what you need to do when you are filling the iteration table, I said it is convenient to use 1 decimal place all through. Is it okay, my student? Then the second technique, ensure in the first iteration, second and the third, the initial value, ensure you fill the burette so that from time to time you start from 0 as your initial value for the 3 or 2 or 4 iteration. Is it okay? So for my case, in the first iteration, I'm starting from 0 and I found out that the final burette reading is 15. Is it okay? Then in the second iteration, I also fill the burette and start from 0. Then the final value is 15.0. The third iteration, the same. I fill the burette so that I start from 0. Then the final value is 15. Then how do I get the volume of solution A used? So what you do, you get the final burette reading, you subtract the initial burette reading. So for example, 15.0 minus 0.0, I get 15.0. The second iteration, the same. 15.0 minus 0.0, I get 15.0. Then 15.0 minus 0.0, I get 15.0. So my student, by so doing, you will have completed the table. And this table will give you 4 marks. 1 for the decimal place, 2 for a complete table, then another one, principle of averaging, then number 4, accuracy mark. Is it okay? But now let us look at the crucial section on calculation, where most of the learners will shy away. But today, you are going to learn something that you will never forget. So, for example, when it comes to question A, calculate the average volume of solution A used. So, solution A was the one in the burette, which is a certified potassium permanganate 7. So this is the volume, the final volumes. So to get the average volume, you take the volume of the 3 iteration, then you divide by 3. Is it okay, my student? If there are 4, you take 4, you add, you divide by 4, and so forth. Is it okay? So in this case, the average volume is 15.0 plus 15.0 plus 15.0 divided by 3, which is equal to 45 all over 3, which is what? When you calculate carefully, is 15.000 centimeter cube. Why do decimal places in the average volume? For accuracy reasons. Is it okay, my student? Let us move to question B. Calculate the concentration of ammonium ion 2 sulfate solution C in moles per liter. Is it okay, my student? So concentration in moles per liter, that is what we call molarity. But we have been given the RFM, that is relative formula mass of ammonium ion 2 sulfate solution. So RFM is equal to 392. Is it okay, my student? But remember, there is a formula. There's this formula. Molarity is equal to concentration in grams per liter all over RFM. Isn't it, my student? But do we know the RFM that is the concentration in grams per liter of ion 2 salt? Yes, of course. Let us go back to what we have been given up there. So when you look at this, my student, that is ammonium ion 2 sulfate solution. The mass was 23 grams, which was dissolved in 1 liter of solution. Is it okay? So the concentration in grams per liter is 23.5 grams per liter. Let us come back to that question B, my student. So the concentration in grams per liter of iron 2 salt is 23.5 grams per liter. Is it okay, my student? What about the RFM? RFM, it is here. From question B, they are saying the RFM of this salt, ammonium iron 2 sulfate salt, is 392. Is it okay? So you take 23.5 grams per liter all over 392. If you calculate carefully, my student, you get 0.06 molar. 0.06 molar. Is it okay, my student? Let us move to the next question. C. Calculate the number of moles. Calculate the number of moles of iron 2 ions in 25 centimeter cube of solution C. Solution C is containing iron 2 ions. Is it okay, my student? The volume is 25. So there is this formula: number of moles is equal to molarity times volume all over 1000. Is it okay, my student? But do we know the molarity of iron 2 ions in solution? Yes, of course. Look at question B above. We have calculated it is 0.06 molar. So the molarity of this solution iron 2 ion is 0.06. What about the volume? The volume, we pipetted 25, so times 25 all over 1000. So my student, if you calculate carefully, you get 0.0015 moles. Is it okay, my student? Then let us move to question D, which is the last question. So using the ionic equation, my student, using the ionic equation for the reaction between manganate 7 and iron 2 ions, you now, which is given below, you calculate the concentration. You calculate the concentration of manganate 7 ions in solution A in moles per liter. So my student, we have been given this equation of the manganate ions reacting with the iron 2 ions in the presence of the acid or the hydrogen ions. Then the products is manganese 2 ion, iron 3 ion, and water. So in this case, manganate ion, being an oxidizing agent, oxidizes iron 2 ions to iron 3 ion. Then the manganate ions are reduced to manganese 2 ions and water. Is it okay, my student? But this equation is very important when it comes to the reacting moles, the ratio in which the moles are reacting, what we call mole ratio. So in this case, when you look at the mole ratio of the manganate and iron 2 ion, is 1 manganate ion and 5 iron 2 ion. So the mole ratio, my student, becomes 1 to 5. Manganate to iron 2 ion is 1 to 5. So my student, the equation is meant to assist us know the moles of one reagent if we know the other. Is it okay, my student? So in this case, we know the moles of iron 2 ions. In question Roman C, look here, my student. The number of moles in 25 centimeter cube of iron 2 ions, we have got the number of moles is 0.0015 moles. So my student, we know the moles of iron 2 ions. So we can calculate the number of moles of manganate ions. Then we use that moles to calculate its concentration. Is it okay, my student? See how it is very simple. So my student, let us continue. So this ratio 5 of iron 2 ion is giving us 0.00015 moles. What about ratio 1? Ratio 1 of the manganate ions. Very simple. Cross multiplication. Is it okay, my student? So if you cross multiply 0.0015 times 1 all over 5, you get, my student, hope you are still watching. So you get 0.0003 moles of the manganate 7 ion. Is it okay, my student? So if we now know the moles of the manganate ions, we can now calculate its concentration in moles per liter, which is molarity. Remember, there is also this formula. Molarity is equal to number of moles times 1000 all over volume. But what are the number of moles of the manganate ion? Look here, my student. We have been given 0.0003 moles. So the number of moles is 0.0003 moles times 1000 all over volume. What's the volume of the manganate ions? It was in the burette, the average volume, which is volume of solution A is the manganate 7 ions, whose average volume, my student, watch, it is 15.00 centimeter cube. So when it comes to this last question, the volume is 15. So when you calculate carefully, my student, molarity or concentration in moles per liter of this solution A is equal to 0.02 molar. So my student, we have come to the end of this lesson, but for more and more questions or sample questions to improve on your performance on calculation titration, please subscribe to Mr. KW channel. Thank you.